Hello everyone, welcome back to Statistician's World. In the last episode, we learned why statistics is the foundation of machine learning. Today, we're diving into the first practical step in any ML project, which is descriptive statistics. This is where numbers turn into insights and insights into smarter models. Before you code, before you model, you look at your data. Because every data set has a story and descriptive stats help you read it. Let's start by asking, what do descriptive statistics actually do for us? Descriptive statistics are like the trailer for your data set, short, clear, and revealing. They tell you the center of your data using the mean, median, or mode. They tell you the spread of your data using a standard deviation or range, and they hint at the shape to see if the data is symmetric, skewed, or full of outliers. So in machine learning, descriptive statistics help us spot problems before training a model. Maybe your target variable has extreme values, or maybe one feature has almost no variation, which means it adds nothing to the model. So that way we prevent from any upcoming problems. Now let's see how it works in a real ML context. Imagine you're predicting exam scores using study hours and sleep quality. Before running a regression or neural net, you calculate descriptive stats. Mean study hours, which equals 5.2, standard deviation equals 1.5, which means students vary a lot in effort. And mean sleep quality equals 6.8 hours. And exam scores ranges from 40 to 95. So just from these numbers, you can already see the story. Some students study more, sleep less, and might burn out. Others study moderately but rest well and possibly score higher. See, you're already hypothesizing patterns. That's the statistical thinking. But here's the point. Numbers alone aren't enough. You need visualizations because visualizations make patterns pop instantly. So descriptive statistics and data visualizations go hand in hand. For example, histogram reveals skewness, box plots expose outliers, and scatter plots show relationships. These are not just pretty charts, they tell you whether your ML assumptions will hold or not. For example, if your data has strong skewness or outliers, a linear model like linear regression might not be a good idea. You may need to transform your variables or use a better model instead. Let's summarize the key descriptive stats you'll always need. When analyzing features before ML, you'll check these: mean and median to detect asymmetry, standard deviation and range to check variability, skewness and kurtosis to understand shape. For instance, high correlation between the two features could mean multicollinearity, which can confuse your model. So the goal is a clean, well-understood dataset, not just a big one. Here's the next step. How do we move from describing data to using it for learning? Descriptive analysis is your launchpad for ML. You're not just computing averages, you're learning the structure of your model. So exploration is where every great data scientist starts with. If you understand your data well, every model you build, from regression to deep learning, performs better and fails less often. That's the real power of descriptive statistics. So let's wrap up what we learned today and what's coming next. Today, we learned how descriptive statistics gives data its voice by showing center, spread, shape, and relationships. Now you know how to see patterns before algorithms do. In the next episode, we'll talk about how descriptive statistics helps understand the distribution of your data and their role in machine learning. That was it. That was the second step of the role of statistics in machine learning. So if you like this video, please click the like button and don't forget to subscribe. This is where your statistical intuition gets stronger. See you in the next one.